In this video, we're going to look at those sample problems again, and we're going to be doing step 2. We're going to identify what parameter is being tested, which comes from the claim, and in particular, the null hypothesis is going to give us the assumed value for that parameter. And once we know the parameter, we're going to identify which of the parameters is being tested. Well, we know which parameter is being tested. We're going to identify which test statistic we're going to use. And once we have that, we'll know what we need from the problem besides the assumed value. We'll know what we need to substitute into the test statistic so that we can do the actual calculation. So let's go look at, well, let's briefly review what we have here. A test of proportion is going to be the parameter p, which means we're using a z test statistic. We need to know p hat. We'll know p from h0. If we know p, we're going to multiply that times q, which is 1 minus p, and we'll also know n. So once we'll have enough information to get p hat, which means we need either an x or an n, or we need to be given p hat directly. For a test of the mean, it's mu is the parameter being tested. It's the t test statistic. And we'll need to know a sample mean, which is an estimate of the parameter mu. And we'll know the value of mu, the assumed value of mu from h0. And we'll need to know the standard deviation of the sample from the problem, and we'll need to know the sample size from the problem. And we'll do the square root, s over the square root of n is in the denominator. So we've got the formulas there. And finally, the formula for the test of standard deviation is called chi-squared, K-I, think K, long I, squared. That squared has to be part of the name of the test statistic, is equal to the sample size minus 1 times the sample standard deviation squared divided by the assumed value of sigma squared. So we'll need the S from the sample, and we'll need N from the sample. Okay, so let's go look at the problems. All right, so if we look at H0, the assumed value of the parameter being tested, we see the parameter is mu, and the assumed value is 70. So our formula requires that we know not only the assumed value, which is going to be 70 here, but we also need to know what x bar is, the sample mean. And we need to know what the sample standard deviation is. And we need to know what the square root of the sample size is. So we need sample size, standard deviation from the sample, and sample mean. And I highlighted in blue the part that talks about a sample and calculations from the sample. So we have the mean speed in the sample was 69.3. So we have x bar. Standard deviation was 7. So we have 7. And it said early on that we had 23 cars. So n is 23. So what we're going to do then is substitute those values into the formula for t, the test statistic for a test of the mean. 69.3 was the mean, minus the assumed value of mu, 70, divided by 7, the standard deviation of the sample, divided by the square root of the sample size, or 23. When we evaluate this, and if you do this on your calculator, you should put a parentheses in the top, on the top, around the 69.3 minus 70, and also around the denominator, around the 7 over 20, the square root of 23. Because we have an operation going on in the numerator, we need to group that together, so that gets done first. And we have an operation, the division here, going on in the denominator, so we need to group that together and do all that before we do this division here. As it turns out, we substitute those in there into our calculator, we get the test statistic is t equals negative 0.480, rounded to 3 decimal places. Now, the important thing here is when we talk about the test statistic, we need to make sure we keep the name of it in there. We need to say T equals that number. We don't just bandy the number about. We have to say that T is that number. Okay, word to the wise. Let's go to the next one. Again, in the problem, or if we look at H0, we see that since we've already done this, found the claim and the corresponding hypotheses, H0 is going to tell us basically what the parameter is and also what the value is. So we know this is a test of standard deviation. And we know the value is 1. That's our assumed value of the standard deviation. And in the problem, I've highlighted in blue the words that talk about the sample and the calculations from the sample. You'll have to identify that in every problem when we're doing hypothesis tests. An experiment where 51 target ranges were measured by the radar resulted in a standard deviation of 1.2 meters. Well, remember what we need for a test of standard deviation from the sample. We have sigma, that's the 1. We need S, which is sample standard deviation, and we need N, which is the sample size. And this gives us a sample size of 51, and it gives us a sample standard deviation of 1.2. So we have everything we need now to go into our formula. And here's chi-squared is equal to the N minus 1, so 51 minus 1, times S squared, so 1.2 squared, divided by the sample, the population, the assumed value of sigma, which is 1 squared. Put that into your calculator. You don't have to add any additional parentheses for this. And we end up with chi-squared equals 72. And keep in mind, whenever we identify the test statistic, we have to identify it by name. Chi-squared equals 72. Let's go to the next problem. We look at H0. We see that this, again, is a test of standard deviation. And we see that we have a value of 0.15, which is the assumed value for sigma in this problem. Now, we need other things besides sigma to calculate the test statistic. We know since it's a test of sigma, we have to use the chi-squared test statistic because that's the one that has the sigma in it. And we also need to know the sample standard deviation and the sample size N, and I've highlighted again the information about the sample and the calculations. We have a sample of 25 measurements, so we have N, and the standard deviation of the sample is 0.185, so we have the standard deviation. We're going to take that information along with the assumed value for sigma, substitute those in. N minus 1 is 25 minus 1, in parentheses, times S, which is 0.185 from the sample, squared, divided by 0.15, the assumed value of sigma squared. That turns out to be chi-squared equals 36.507 to 3 decimal places. Okay, let's go to the next one. This is, if we look at H0, this is a test of the mean. Mu equals 0.667. So the assumed value for mu is 6.67. And since we know we're testing mu, we need to use the T test statistic, okay? The T test statistic. And besides the assumed value of mu in there, we need to know X bar, the sample mean, and we need to know S, the sample standard deviation, and we need to know N, the sample size. I've highlighted in here, which you would have to do, or you don't have to highlight, but it might not be a bad idea. Highlight the sample information, not the claim information, but the sample information now. And we see we have a sample of 31 cars. There's N. We have a mean of 5.65. There is mu, or I'm sorry, X bar, and we have a standard deviation of which is S of 1.2. We take those three pieces of information along with the assumed value for mu, substitute those in, and we see that we've got X bar, which is 5.65, minus 6.67, which is mu, divided by S, which is 1.2, over the square root of n, which is 31. And again, if you're doing this on your calculator all at once, you need to put parentheses around the numerator to make this subtraction happen first. And you need to put parentheses around the entire denominator so that this division, the square root happened first, and then this division would happen. All that before it does the final division. And we see that the result is, the test statistic is T equals negative 4.733. And again, T, you have to identify the name of the test statistic when you state it. T equals negative 4.733. And let's go look at the last two. We haven't seen any proportions yet. Well, guess what? These last two are tests of proportion. But how do we know that? Well, we look at H0 and we see, because we've already done this, we found a claim and alpha, and we found and created the hypotheses. We see that the proportion P is being tested here, and we're given an assumed value for it of 0.7. What do we need besides that? Well, in the formula, remember, we need P hat. Okay, so we need enough information to give us P hat. So we either need X over N, which we'll use to find P hat, or we'll have P hat and N, because we need P hat and N in the formula, as well as P. And we also need to know Q, which is 1 minus P. So once let's look at the highlighted area here for the sample information and calculations. We see that the researchers found that they had 45 patients. There's a number of trials, N, and 27 were migraine-free. There's a number of successes, X. So we have X over N. We can calculate X over N, which is 25 or 27 over 45, which turns out to be 0.6. So we've got P hat as 0.6. And we take the P hat of 0.6, subtract the assumed value of P as 0.7, and divide that by the square root of P, again, 0.7, times 1 minus P, which is 0.3, that's Q, divided by 45. Now, if you're doing this on your calculator, you need to make all at once, you need to put parentheses around the top. That's the only place you need parentheses in this for test of proportion. To find Z, you put parentheses only around the top. We evaluate that, we end up with a test statistic of Z equals negative 1.46. So we've got our test statistic value. And finally, another test of proportion. We look at P, or H0, we see the proportion P is being tested, and the assumed value for P in our test statistic is 0.13. We also need, again, either X and N to get P hat equals X over N, or we need P hat and N. So this problem is giving us, in the highlighted region here for the sample, we have a sample size of N equals 200, and we have a P hat given to us. We don't have to calculate P hat, it is given to us directly. As a percent, we would have to divide that by 100 to get 0.078. Take all of that information, including the assumed value of 0.13, substitute it into the test statistic formula, and we get P hat of 0.078 minus 0.13, the assumed value of P in the numerator. And in the denominator, we got the square root of P again, 0.13, assumed value of P, and 1 minus the assumed value of P, which is 1 minus 0.13, which is 0.87. And we're dividing that by N, which is 200. Again, put parentheses around the top when you're finding the proportion test statistic, Z. And we get z equals negative 2.19. So that covers all of the, all 6 of these problems. And that covers step 2 in all 6 of these problems. Okay, so stop share.